Let's now introduce the word2vec algorithm. Previously, we saw how we could train word embeddings together with language models. Now we will use word2vec algorithm for producing word embeddings. Actually, this algorithm was published in 2013. At this point, it's mostly important for historical purposes. Word2vec evolved from language model research. They made the observation that language models learned embeddings that had interesting properties. This then led to the evolution of building the word2vec algorithm. This is a multi-step process shown in this figure. And the authors of word2vec started from a language model with a fixed number of words as input. Then they simplified this model to reduce the computational complexity. They removed the hidden layers and they replaced it with the softmax. The softmax, they replaced this layer as well with something known as hierarchical softmax. And then this enabled them to train the model with more data, as you can see in this figure. And they showed that the training it on more data resulted in a better embeddings. Note that removing layers and doing these changes resulted in the word's language model, but the goal of this process was not to build a good language model. The goal was to produce good word embeddings. It's also worth noting that this was in 2013, so it was more important to reduce the computational complexity because they didn't have as much computational resources than as today. A second step after reducing computational complexity was to not only use words from the past as inputs, but also they started to use future words. Modified model predicts word number n from 2 words before it and 2 words after it. For a language model, you wouldn't have future words available, but it does make sense that it's good to use them if you want to produce good word embeddings, because a word will have relationships both with words preceding it as well as the subsequent words. Now there are some versions of word2vec. I will talk about, first of all, about continuous back of words flavor. Another change was they started averaging the embedding instead of concatenating them. But that is that this model will ignore the order, the word order. The model shown on the slide is known as continuous bag of words version of word2vec. The term bag of words is a term used in traditional natural language processing models. It's a model that also ignores the word order. And that's why they chose the term bag of words in this version. The continuous part of continuous bag of words is because word vectors are continuous variables. Note that the continuous bag of word model is not the same thing as bag of word model. Continuous bag of words is used to produce embeddings, while a bag of words is typically used to summarize a document. Another version of word2vec is skip-gram model, also called continuous skip-gram model. This is the more common version of word2vec. It flips the problem around. Instead of predicting one word from the surrounding words, it's predicting the surrounding words from a single word. It also changed that they replaced the hierarchical softmax by something known as negative sampling. So instead of having softmax layer on the output, we have a single neuron, a single sigmoid neuron corresponding to each word in the vocabulary. We then present a single word as input to the model, and we train the outputs for the surrounding words to the output of the value 1. However, if we just did that, it would be easy for the model to cheat by simply making a model where all the output words always are 1. So therefore, we need to also introduce something known as negative sampling. We pick a number of random words and train those words. So these are random words that are not surrounding this one word. And then we are training the neuron corresponding to those words to output 0. So this made for a very efficient training process. In terms of terminology, they named this model the continuous skip-gram model because skip-gram is the term coming from the traditional natural language processing community. It's a variation on n-gram, but we are skipping some words. Again, the continuous skip-gram model is used to create embeddings, and that is distinct from the regular skip-gram model, which is a building block in a language model. Word2vec was significant in that it demonstrated the power of word embeddings. The authors of word2vec also made pre-trained embeddings available to download, and that was used as the basis for other models. This is an early example of the concept of transfer learning applied to natural language processing. Word2vec also sparked further research in embeddings, and in upcoming sections, I will show you programming examples with pre-trained glove embeddings, and I will talk about another embedding scheme known as word pieces.